You know that rule from math class, the one that probably made you scratch your head? A negative times a negative is a positive? We're all just told to memorize it, but the real story behind it is so much cooler. See, a lot of math rules weren't just discovered lying around waiting for us. Nope, they were invented by people to solve really specific problems. So let's get into that story.
Okay, to get started, just imagine a world with only the numbers you first learned about in school. 1, 2, 3, 4, 5, and so on. In that world, a simple question like 5 minus 8, well, it's impossible. It makes no sense. You can't take away 8 apples if you only have 5 to begin with. The number system we had was, well, incomplete. It had this huge blind spot. And this wasn't just some abstract idea for mathematicians. Think about it in real life. You can do 500 minus 200, easy. But what about 40 minus 50? You just hit a wall, right? You can take 40 away from the 40, but then you still have 10 more you're supposed to subtract. What do you even do with that leftover 10? There was no answer.
So, to solve this crisis, humanity needed a real breakthrough. And it wasn't a discovery, it was a brilliant, totally creative invention. People decided to just imagine an entire new world of numbers, sitting right there on the other side of zero.
Now listen closely to the words here. They proposed it. They suggested it. This wasn't something they found in nature. It was an idea they came up with, probably argued about, and then finally agreed on because it was so useful. They basically just said, hey, when we have to do 10 minus 20, let's just call the answer negative 10. It was an agreement, a human invention.
And with that one simple agreement, our entire number system just blossomed. It wasn't just the counting numbers anymore. Now we had the integers, this complete, perfectly symmetrical set of numbers stretching out to infinity in both directions, positive and negative, with 0 right in the middle.
But here's the thing. Inventing a bunch of new numbers created a whole new set of puzzles. It's kind of like discovering a new continent. Great, but now you have to figure out how everything works there. What are the rules of this new world? How do these new negative numbers get along with the old positive ones?
So here's the absolute key. For this new system to be useful, it had to be consistent with the old one. Look at this problem. We all know that to get from 15 down to 10, you have to subtract 5. Simple. But the problem here is set up as an addition problem. So mathematicians had a puzzle. They needed to invent a number that when you add it, does the exact same thing as subtracting 5. And this right here is the brilliant solution. It was just another agreement, a decision. They literally said, okay, from now on, let's define the number negative 5 this way. The very identity, the whole point of negative 5 is that adding it is the exact same thing as subtracting positive 5. They are the same action.
And this is what that agreement looks like in practice. The math on the left and the math on the right look totally different, right? But because of that rule we just made up, they mean the exact same thing. They both get you to 5. This became one of the foundational rules of our brand new system.
This leads to this really beautiful and powerful idea called additive inverses. Basically, every positive number has a negative twin, its exact opposite. And when you bring them together, when you add them, they perfectly cancel each other out and get you right back to 0. It's like taking 5 steps forward and then 5 steps back. You end up exactly where you started. And this whole idea of opposites is what makes the system work so perfectly. Check this out. Why is 8 plus negative 5 equal to 3? Well, let's just think of 8 as being 3 plus 5. So now the problem is 3 plus 5 plus negative 5. Well, we know that the 5 and the negative 5 are opposites. They're additive inverses. So they just poof, they wipe each other out and become 0. And what are you left with? Just 3. It's not magic, it's just a perfectly logical and consistent system.
Okay, so we've got addition and subtraction figured out. But now we get to the big one. The rule that feels weird. The one that trips everybody up. Multiplication. Why on earth is a negative times a negative a positive number?
Well, the answer, believe it or not, comes right back to that word, consistency. There's this super important fundamental rule in math called the distributive property. All it says is that multiplying a number by a group of numbers added together is the same as doing each multiplication separately and then adding them. This statement you see here has to be true. It's non-negotiable. If it's not, the whole system we've built just falls apart. All right, get ready for the final leap of logic. Let's use that exact same distributive rule, but with a negative number out front. First, let's solve the left side of the equation. Inside the parentheses, 5 plus negative 3 is just 2, okay? And negative 10 times 2 is negative 20. Simple enough. So because both sides of the equation must be equal, that means the stuff on the right side must also equal negative 20. We already know the first part on the right side. Negative 10 times 5 is negative 50. So now the question is simple. Negative 50 plus what gets us to negative 20?
There is only one possible answer. The missing piece of that puzzle, the value of negative 10 times negative 3, has to be positive 30. It's the only number in the universe that works. We are literally forced into this conclusion. Not by some law of nature, but by our own demand that the system of math we invented has to stay logical. We have to agree that a negative times a negative is a positive, otherwise the whole beautiful structure just collapses.
So there you have it. That rule you had to memorize isn't arbitrary at all. It's the only possible rule that allows our number system to work without breaking itself. Negative 10 times negative 3 must be positive 30. It's a logical necessity that was born from the other rules we'd already set up. And by making all these clever agreements, these brilliant little inventions, we ended up creating a system of numbers that was way more powerful and complete. A system that could solve problems the old one couldn't even begin to describe.
And this new multiplication rule has some really fascinating consequences. For example, look what happens when you square a number. We know 10 times 10 is 100. But now, because of our new rule, negative 10 times negative 10 is also 100. How weird is that? Suddenly, two totally different numbers give you the exact same result when you square them. And this totally enriches our whole understanding of things like square roots. It means that a positive number like 100 doesn't just have one square root, it has two of them, a positive one and a negative one. Our mathematical world just got twice as interesting.
So when you boil it all down, the entire world of integers is built on just a few key agreements. These are the rules we humans made up to make sure our number system was consistent, logical, and powerful. They weren't handed to us on stone tablets. They were a collective human invention.
And that kind of leaves us with a final, bigger thought. We accept this really strange-sounding rule that two negatives make a positive because it's the only way to keep the whole system of logic from falling apart. It really makes you wonder, doesn't it? Where else in our lives, in our laws or our social rules, even in our language, do we accept ideas that seem kind of strange on the surface, all for the sake of making the whole big system make sense?